Okay, so now we're going to look and determine how we can look at the shape of these molecules. Because remember, molecules aren't 2D, they're actually 3D. So the first thing we have to do is write a Lewis structure. So if I look at on page 10 here, we're going to do a few of these. We're going to look at BH3. So I have 1 boron times 3 valence plus 3 hydrogens times 1, so I have a total of 6 electrons. So I have boron in the center and my hydrogens surrounding around it. Okay, so now remember, hydrogen is one of my exceptions, and he's perfectly happy with 2 valence electrons, and I have no more electrons to show in there. So here we go. Everybody wants 8 except my hydrogen, and I'm going to add another one here, my boron. Okay, so he is actually happy. Boron we won't see too many times. Okay, so now this is the correct Lewis structure. So now we move on to what do we call an electron group? Okay, in order to look at electron groups, we look at that central atom, the atom that is in the center. When we refer to electron groups, we look at the things that are coming off of that central atom. So what constitutes an electron group? When we have one lone pair of electrons, that is one electron group. When we have one single bond, that is one electron group. When we have one double bond, that is one electron group. When we have one triple bond, we don't see triple bonds too often, but when we do, that is referred to as one electron group. So if we look at my BH3 here, I take a look at boron. I have 1, 2, 3 electron groups. So I'm going to put a number 3 here. And now in terms of electron arrangement, we're going to flip to the last page, and I have a nice little chart. So you'll notice on the left-hand side, I have number of electron groups. I have electron arrangement, and then I have what my shape is. And the shape changes based on whether those electron groups are bonds or lone pairs. So in this case, I have 3 electron groups, so my electron arrangement is trigonal planar. So I'm just going to come back over here and write trigonal planar. And then my geometry, the actual shape of the molecule. I'm going to go back to that last page. And I look, okay, I had 3 bonds and no lone pairs, so my shape again is trigonal planar. So I just write trigonal planar. Okay, so let's look at this next one now. SCl2. So sulfur has 6 plus 2 chlorines. Each of them have 7. So we have a total of 20 electrons that I need to show. So I'm going to put sulfur in the center, my 2 chlorines coming off. Again, everybody wants to have 8. So we're going to do 6. That makes chlorine happy with 8. Put 6 more here. That makes chlorine happy with 8. So I have a total of 16 shown. So I have 4 more that I need to show. My sulfur isn't quite happy yet, so I'm going to throw those right there. So now just double check. I have 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 electrons. So we're good to go. So now we look at our number of electron groups. I have 1, 2, 3, 4 electron groups. I have 4 things coming off of it. So if I fly to my last page, 4 electron groups, it is tetrahedral. So all right, tetrahedral. And now in terms of shape, so notice how I had 2 bonds and 2 lone pairs. So if I look at my chart, I had 2 bonds and 2 lone pairs. So my shape is actually bent. And as you do these, I'm going to have you build them with the models that are in the beakers up in the front. So you can actually see that that molecule is actually bent shape, not linear in fashion the way that I actually drew it. What I want you guys to do is actually finish pages 10, 11, as well as 12.